Many desktop-class AI models are designed to operate securely on local hardware, keeping proprietary code within your own private network. We are configuring this environment so the agent independently analyzes, tests, and commits code based on your project's specific requirements. This setup requires a high-memory machine, specifically an M4 Pro with at least 48 GB of RAM to support the Qwen 3.6 MLX model. Reaching this level of performance requires overriding the standard software defaults to utilize the hardware's full memory and reasoning capacity. We begin by modifying the model registration file, models.json, which defines the AI's memory boundaries. Standard settings often limit the context window, causing the AI to lose track of project details when reading larger files. We are increasing the context window to its native 256,000 tokens and setting the output ceiling to 32,000. This expanded window prevents the agent from truncating code, allowing it to ingest multiple complete files simultaneously without exceeding its memory buffer. Providing this high-capacity working memory allows the AI to evaluate your entire codebase as interconnected. Next, we adjust the runtime tuning parameters within the settings.json file. The thinking budget determines how many internal tokens the model can use to reason through a problem before it begins writing the final answer. We are tripling the thinking capacity to 24,000 tokens, providing room for complex logical pre-computation. Crucially, the output limits in this file must mirror the 32,000 token threshold set during registration, or the environment will fail to launch. Increasing the reasoning depth while maintaining low temperatures will result in a noticeable reduction in the model's overall output speed. Prioritizing deep reasoning tokens over quick responses ensures the model's output becomes deliberate and technically accurate. Before proceeding, we must verify that the new configuration files are structured correctly. Run the JQ command in your terminal to validate the syntax of both JSON files. This ensures no commas or brackets are out of place. These background launcher scripts are read-only at startup and don't support hot reloading while running. You must execute the /startcoder.sh script to terminate the current session and reboot the environment entirely. Without executing this hard reboot, the configuration updates you just implemented will remain dormant. Now we can test the environment by moving into a local project directory like PyTest. You can control the testing and staging pipeline using natural language shorthand commands. Phrases like run check execute a script that runs rough, PyTest, and Pylint in one sequence. A single commit command triggers a parallel chain of code linting, testing, and git staging. If any of those parallel tests fail, the pre-commit hook failsafe triggers, preventing the upload and requiring you to fix the code before proceeding. This integration allows natural language to serve as the primary interface for complex, multi-step validation tasks. You now have an AI environment operating at maximum context capacity, integrated directly into your local Git workflow. If the agent forgets its command mappings during a long session, you can recalibrate it by simply restating the instruction. Remember, check means make check. As your personal toolset grows, you can return to these files to adjust specific token budgets for new skills or knowledge bases. The end result is a highly tailored, completely offline computational partner, perfectly configured to your specific hardware and your daily development pipeline.